Welcome to GATE CSE. We'll continue with our series GATE CSE 2026 Pattern Analysis and Most Frequently Asked Questions for this particular GATE exam only. So now we'll see the OS concepts, what OS concepts they can ask and what type of questions they can ask. So when compared to computer organization, you can expect 1 or 2 marks less than computer organization this time. So you can expect around 6 to 7 marks. And then you can expect 2 marks questions, at least 3 questions, and 1 or 2 mark questions. So similar to your computer organization, the OS pattern this time will also follow similar to your OS, so your COA. Okay, so the questions usually look long. Okay, cannot expect a simple process scheduling table given and then ask you to find the waiting time and all those things. The question, you may have to form your own table. Okay, the question may look big. I'm not saying the questions will be difficult. The questions may look big. You may feel too much of information given, but they're just like a storytelling. They're telling problem as a story. So you should filter useful information. So they will be mostly logic based, not formula based again. So for GATE exam, for any subject, do not go based on the formulas. Formula may apply only in the ideal or assumed conditions. Some conditions you'll assume and then you derive a formula. So please don't mug up the formula. You understand on what assumptions you got that formula. Then in the exam, based on the question, you derive the own formula according to your procedure. So in OS, 1 mark question you can expect to be tricky. Okay, they will not be complex, they will be tricky. Okay. In OS, the pattern mostly we observe is they will change or put some restriction or condition on ordering priority. This is very important. And then timing, okay, how they are allocated, how they are not allocated. So the best thing is you just simulate based on your understanding like what is happening, and then you can easily solve the question. The computations will not be very heavy. So let's start with the topic. So you can expect definitely one question on process scheduling. Most likely it will be a 1 mark question, and it will be a tricky question. It will not be straightforward question to find something. Okay, so it will be on the behavior of the scheduling algorithm. So they will not ask first come first serve, means you just put a Gantt chart and then find when it completes or what is the average waiting time and all those things. You can't expect such question, but behavior will be same. The answer what you get will be based on that only, but only thing is there will be some change in the ordering or priority, something like this. So most commonly one question you can expect on SRTF is shortest remaining time first, or first come first serve, and round robin. The underlying concept behind all these 3 algorithms is nothing but your preemption and non-preemption. Okay, this is where they test your understanding. So the question may ask for how much time it may store, or fairness, that is waiting time, then response time. Often include execution order tracing, in which order they may complete, or what is the completion time of a particular process. Such questions they may ask. So what is that you have to be careful, because it will be tricky question. You should be careful with the whether it's a preemptive or is there any priority inversion involved. Okay, you may not ask the direct definition of what you mean by priority inversion and all. So they will frame a question such that inside that question there will be an underlying assumption that there is a priority inversion. That is what you have to be able to identify. So that is about process scheduling. Then when it comes to semaphores and synchronization, so definitely in synchronization they can ask on binary or counting semaphores, most likely binary semaphores, which uses wait and signal protocol. I suggest you please understand this. Okay, the function. There are multiple implementation you can see on the internet. So you follow one GATE standard. You refer to the previous GATE solutions and then assume that, okay, or understand that how the wait and signal works. So most likely they will ask the output which forms a particular pattern, or they may give a pattern and then tell in which order I have to put this weight or signal operations in my process. So also they may check what is mutual exclusion guaranteed or progress guaranteed, or is it deadlock free, and all those things. So once you understand the working of weight and signal and the sequence, the pattern, then definitely you can find out. You should understand the definition of progress. Mutual exclusion you will easily understand. You understand the progress and bounded weighting and deadlock conditions. So question often asks which assignment works, not how it works. We already know how it works. They'll ask like what are the possible combination or what is the pattern which will lead to that particular result. So execution trace matters. When you solve the problem, so the trace means when a value is applied, when a value is given to that variable, so what is it that will get as the outcome. Okay. Then when it comes to deadlocks, you can expect very big questions on this, 2 marks questions. The question will be big because they have to give a lot of constraints, conditions, and all those things. In examples, we'll see how they may frame the question. They may not give the direct values and then ask you to find whether it's deadlock possible or not. So they may give indirectly. You may have to use your source allocation graph or Ranker's algorithm to find safe and unsafe state. Okay. So this procedure is simple. The only thing is how you apply for the given question, because the question may not give you the direct values. So you have to check existence of deadlock, that is safe or unsafe state. So one question you can expect is using integer reasoning, means they'll ask that there are some X processes or resources. What is the relation between these two such that there is no deadlock? Okay, for given constraints or conditions. See, you already know the relation between these two with direct formula, but they may change that conditions if it is dependent on like this. For example, all even number of processes excesses even number of resources. So in that can be a condition they can put. Then you have to just adjust that based on the conditions. Then when it comes to paging and memory management, okay, so two things. One is average memory access time. Definitely they will ask on this, which may include both TLB as well as your page fault rates. Okay. This is where you should not apply formula. Formulas will not work here. The formulas are derived based on some assumptions in your notes or in your classes where you have gone through. So in the exam, you have to read the question carefully. What are the assumptions they are making, and then how it works. So my suggestion is you go through the procedure. So how TLB works, how the page fault service is done. So there are different steps. Once the page fault occurs, there are some steps you will follow. So you logically should follow the same steps. That should be in your mind, so not the formula. So with some tricky access patterns can be asked when for the page replacement algorithms like P4 LRU. Okay. So they may ask the reverse order or repeated access or infinite access like that. When it comes to disk scheduling, I think it will be a simple question most likely. So they may ask probably on SSTF, shortest seek time first and scan. You have to understand the behavior. Okay. In that, they may not directly ask how many seek movements I am doing. They may ask, attached to it, some say what is the power consumption. If I do certain seek movements, I will consume say this many watts or energy. So how much energy I will save or how much energy is spent. That kind of questions they can ask. So that's basically aptitude question. So this initial head position is very important and the direction in which you move. Okay. When you start your algorithm, in which direction you will move. So that is based on the concept of queue, because all the requests are queued. So you know how the queue works. For that particular algorithm, you should know which direction it is moving. Let us see some examples. The question will look very big like this. So this is just a process scheduling algorithm. They are given the CPU burst time as well as IO time. So CPU burst time as IO time. So if you very confident directly, you can draw the Gantt chart from the data given here. Else you can just form your own table. So what I'm saying is they will not give the direct table like this. In previous old GATE, they used to give this table and then ask you to find. But here they are not giving. They are giving this time, priority is given, IO time is given, burst time is given. So you have to form your table. You are not confident directly to solve from this. So it may take 1 minute extra, but we'll get 1 mark definitely. Okay, so if you solve like that, we'll get the answer as 27. Similarly, they may mix some concepts of context switching, scheduling algorithms, and synchronization. Okay, so for example, you may not directly expect based on only scheduling. So scheduling includes context switches, and then when synchronization also requires context switch. So the resource may be anything here. Okay, the resource may not be only CPU burst. They may include the CPU burst plus some other things. For example, mutex, the synchronization mechanisms. And then ask you how many context switch occurs, or for getting a particular pattern, what is the order of process execution, and all those things. So which scheduling algorithm is used, that is also you should be very careful, because round robin is mostly they'll ask round robin in many GATE exams, because this every student feel that round robin is very simple, but actually underlying queue is very important. How you, when you preempt a process, you place it in a queue. If you miss this queue, then you'll get a definitely a wrong answer. Okay, so that is a trick here. So if you solve this, you will get the answer as 26. Now, on synchronization, most likely you get a question on semaphores, and semaphores, they give some say 3 to 4 processes like this, and then the order of wait and signal, and then they may print some patterns. Okay. So here in this question, they are asking, assuming no starvation and arbitrary scheduling, determine the minimum number of context switches required to print this sequence A, B, C. So you can start with any process, because they are saying arbitrary scheduling. So P2 may come first, or P1 may come first, or P3 may come first. So that is also important. The order will be very important. Okay. Always don't jump with P1. Now you start. So if you start with any process based on this semaphore values, you can find out that pattern. When I find that pattern, so I will come to know how many context switches occurs. To find the number of context switches, you have to first find the order of the processes in which they are scheduled. So for example, to get ABC, if you observe here, I should schedule the process in this order only. P1 should come first, P2, then P3. Again for ABC, same thing continues, P1, P2, P3. From here only you can identify how many context switches open. So this is how the questions will be framed. See, they will not be computationally intensive. Okay, they will be only tricky. So if I find out this pattern, then definitely I can directly count and answer them. So most of the questions will be like this only. They will not ask you to solve like pages of answers. And one more question you can expect on bounded buffer. Okay, bounded buffer or dining philosopher's problem. That is the mutual exclusion and synchronization problem. So these will be actually simple. They may give statements and assumptions like this, or they may give the code. In the previous example, you have seen the code like that. So based on that, you just have to find the pattern or logical sequence. See, synchronization means what? Finding a order in which there is no inconsistency. That is the ordering. Okay, the ordering of the processes such that they complete and then there is no delay or starvation. So based on that, as in the previous example, you can just find out what is the maximum number of items that can be present in the buffer at any time. So they are saying there is a buffer, that is the concept of bounded buffer. So its size is pi. So that it is shared between processes, two consumers. So there are two producers who keeps on producing, and there are two consumers who keep on consuming. So at any point of time, you have to follow that rules, two rules, the overflow and underflow. So based on that, you have to place your empty, full and mutex, that is wait and signal, using these semaphores, and then find out how many context switch may occur for the correct execution. Now, when it comes to deadlocks, again, the question will contain lot of data and lot of constraints. Okay, so you should be careful with this data. And then the second is very important, the conditions. With the direct formulas that you have learned for your standard bankers algorithm or RAG using RAG, okay, that may not apply to all the questions. Okay, they have to observe carefully what are the additional constraints they are putting or what are the additional assumptions they are making in your question. For example, here resources are requested only when previous ones are held. See, this is an additional condition here. If you apply your old formula, it may not be working and release only after all requests are satisfied. That means hold and wait. What is the maximum number of resources that can be allocated simultaneously without causing the deadlock? We already know this conditions. So where Mi represents maximum demand for each process I is less than R. So sum of all this minus 1 is less than R. This is the derivation. So if you understood the formula, it's better you understand how you obtain that formula in your standard cases. How I obtain this, the derivation is very important. That actually gives you step-by-step idea that how to solve a problem. So these are the conditions for this problem. Deadlock impossible. This. So in the exam, you may have to assume and derive like this. When I say derivation, you did not sit and derive it. So you can just for each option or for each, just you can mention. So this is one case. This is another case possible. This is another case, and this is another case. So that is you can do it in mind, or you can just write it on our workbook and then find out the answer quickly. Okay. Don't ever mug up these formulas; they will not work. Similarly, on deadlock, you can again find pattern based questions. For example, say that here in this question they are asking, so there are some K processes and then there are say R resources. K processes, R resources, and then they are putting some constraints here. Each process first requests exactly one resource. This is the first step. After acquiring one resource, it may request one additional resource. So to request two resources it wants. A process releases all held resources only after completing execution. That means hold and wait. It will not release till it gets both the resource. At most one resource can be requested at a time. So I cannot request more than one request at a time. So additionally, the system enforces the following constraint again. What are the conditions to allocate this resource? Process with even index. So P1, sorry, P2, P4 like that request their second resource because already one resource is given for everyone. Only if the total number of free resources is even. At that point of time, if R is even, then I will give it to process with even numbers P2, P4 like that. If process with odd index requires their second resource, only if the total number of free resource left is odd, then I will give it to odd process. That is, they are trying to break the cycle here. See, there are 4 conditions for deadlock, that is necessary and sufficient conditions. All 4 should hold for a deadlock to happen. So they are trying to break one of these, like for example, cyclic wait, circular wait. So now, based on that, they are asking a question. This is the integer problems. So they are giving some integer values for K and R. This is number of process and resources. And they are asking you which one is not caused deadlock. Okay, deadlock is impossible. So in that you have to derive our own formula or relations or conditions. Here in this, for this example, I have given it here. So there are 3 possibilities possible for any deadlock allocation problem, for resource allocation problem. These 3 you have to check. Okay, these 3 you have to check. What if the resource is greater than number of processes? What if they are equal? What if they are less? Then according to that problem, okay, this is not universal, means it will not apply to every problem. Okay, based on this problem, this is possible. So for like this, you have to find in the exam for the given conditions. Given here, you can go through it. So you have to think in that angle. So formulas always do not work. So if you check that, so you'll get which are the possible answers. So deadlock is impossible only when R is greater than K. So based on that, you can make your assumption. Then So one question you can expect on the TLB hit and miss. Again, here most of the students, even knowing the concept, make or get the wrong answers because they don't understand or read the question properly. The formulas you apply directly, you may not get the correct answer always. So you have to read the question properly, what is the assumption they are making, and you should always have that imagination that how the excess takes place. If there is a TLB hit, then what happens? If there is a TLB miss, then what happens? If TLB hit, then there will be page fault or not. If the TLB hit, then cache hit will occur or not. So that kind of conditions you should keep in mind. And also observe the question carefully. Okay, some questions may explicitly say that TLB miss means always page miss or page fault will occur. That kind of conditions you may have to check in the question, read the question properly. So this here it is, they are given 2-level page table. Okay, and then given the number of entries, memory access time is given. Okay, so if you see here, they're asking for average or effective memory access time. So sometimes they may get some information which are not required. Okay, in this, what is that I required? I required only to calculate effective memory access time. How many levels of page tables is sufficient? Okay, how will you derive the formula for it? The exam. So first you start with the procedure. First hit TLB hit. If it is a hit, then get the address from the TLB and then do the memory access to get the data. If it is a miss, then so you have to add that penalty TLB search time plus n is number of levels, because it is multi-level paging. Say for example 2-level paging. In the first level I have address of the second level, right? So for that, to get the address, you have to do n memory accesses if there are n levels. This will give you the address. Then you have to get the actual data. So this is how the procedure works. Next. So they may also include your page faults and then the conditions. See, for example, if you directly apply the formula, you may be already knowing the formula to calculate effective memory access time when the page fault is given. But that formula, if you apply, it will not work here. Why? See, if you observe here, TLB misses causes page faults. See, this is very important here. If you miss this point, then you'll get a wrong answer. Why? Because they are saying, if you assume your formula, your formula assumes that all TLB misses may not cause a page fault. But here they are mentioning any TLB miss will definitely cause a page fault. That means that is not present in the main memory. You have to go to the disk. So for that they are given disk access time also, because it has to do the IO operation. And then in that disk they may also again include if the page is dirty. That means page has been used by some other process or the same process. Okay, and then it has to be returned back and then replaced. And then TLB has to be uploaded. So this is the procedure of page fault service. Okay. There are 6 or 7 steps to understand carefully how it works. Then based on that, you can easily derive the formula, because you'll first go for TLB, then you'll go for TLB hit, then find the TLB time plus memory access time. If it is miss, here they are directly saying you go for page fault, TLB miss. So that also have to include. And then again in the page fault handling, you have to check for page dirty and not dirty. So point 4, TLB hit, then do memory access. If it is miss, then the TLB search penalty plus 2 times the memory access to get that address, and then disk access plus, if it is dirty, again I have to 50% of the time I have to write it back. So this is the final answer. Now they may also ask a question on some disk scheduling like scan, look, see, look, and all those things. So they are simple. Only thing is your direction and the head movement matters. Okay, so you solve these questions using the concept of queues only, because all the requests are queued. Okay, so just if you understand the procedure, that is not fine, because you need to know the direction, okay, and then head movement. Okay, so if you solve it, it will be fairly simple. You may expect 1 mark question on this, but it will be tricky, because this underlying assumption they will test. Definitely they will test. They will give a sequence such that if you won't use this, you will definitely make a mistake. In the next video, we'll dissect the database management system topic. So till then, please like, subscribe and share. Thank you for watching.